morning, children. This application of maxima and minima, that is application of derivative, is having more importance, very important, because this will be used for many practical problems in our day-to-day life. So we will be having more session on this topic, and for your CBSE examination, there is surely a 6-mark question will come from this maxima and minima. So I may be taking one more week with this maxima and minima, explaining the word problems. And daily 2 problems I will explain and put in the WhatsApp as a video link, and then along with that the PDF file also I will be sharing. And daily some 5 questions also you have to answer for it. Now today I will discuss the first question. The question is, of all rectangles inscribed in a given circle, square has the maximum area. So the word is the square has the maximum area. So when we maximize the area of the rectangle which is inscribed in a given circle, so it is a fixed circle, there is no variation for this one. It's a fixed circle means the given radius. The radius is given, a fixed radius. Say let us take R is the radius of this one. So we will be inscribing a rectangle. The rectangle can be inscribed in many ways. See, I can have like this. That is one way. And I can have like this. So it is you can call it as a variable rectangle. The dimensions of it are varying. We want to know that what way the dimension should be, so that the area of this rectangle is maximum. Or in another way, when the area of this rectangle is maximum, this rectangle will become a square. How the rectangle will become a square? When the length and breadth are equal. So let me take x as the rectangle's length and y as its breadth. So what is the area? Area function will become x, y is the area of the rectangle. We have to maximize this area. That means you know the condition of maxima. First derivative is 0 and second derivative is negative for maximum. So when you want to maximize, you have to differentiate this one. Application of derivative comes there. You have to differentiate. Now there are 2 variables, x and y. You cannot differentiate now directly. So we need some conditions to convert one variable in terms of another variable. Now see here, the diagonal will pass through the center. The reason is that you know in class 10 you have studied that angle in a semicircle is a 90 degree. So by that condition, the diagonal of this rectangle will pass through the center. Now I have taken the radius of the circle as r. R is the radius. So thereby this becomes 2r. 2r is the diagonal of it. Now from the figure you can see that x square plus y square is equal to 2r square. That is by Pythagoras theorem. Or y square is equal to 4r square minus x square. Or y is equal to under root 4r square minus x square. So you got y. That y in terms of x. So the area function now becomes x into y. That is 4r square minus x square. So now it has become in a single variable x. So we can apply the maxima and minima condition. Maxima condition is area is maximum. That means first derivative of a is equal to 0 and its second derivative should be negative. Now let me simplify the sense into avoid to simplify the steps of differentiation, I will put this x inside. So when you take this x inside, what happens? It goes inside the root x square. So 4r square x square, and this x square into x square x raised to 4. So it will become easy for us to differentiate. Now for maxima, dA by dx is equal to 0 and d square a by dx square is equal to negative. That is what we have to say. Now we will find out dA by dx. dA by dx equal to 0 when it is taking like this. Derivative of this one, root x derivative is 1 by 2. So 1 by 2 root 4r square x square minus x raised to 4 into d by dx of this expression. What is that expression? 4r square x square minus x raised to 4, and that is equal to 0. dA by dx is equal to 0. So when you take it is d by dx 4r square x square, 8r square x minus 4x cube divided by 2 into 4r square x square minus x raised to 4. And you cross multiplies, you will get 8r square x minus 4x cube is equal to 0. And here 4x is a common, you will have 2r square minus x square is equal to 0. You will get x is equal to 0, and here 2r square minus x square is equal to 0. So x square is equal to 2r square, or x is equal to root 2r. We take only positive because x is the dimension here. So it will never become negative. So I put x is equal to root 2r. So you have two values, x is equal to 0 and x is equal to root 2r. And x is equal to 0 is also not possible because when x is equal to 0, that is length of the rectangle becomes 0. There is no rectangle at all. So only the possible value of that is x is equal to root 2r. Now this value we got by equating the first derivative is equal to 0. We know that for maxima as well as the minima, the first derivative is 0. So we have now identified, we have to verify that whether this is a maxima or minima. For that, second derivative is to be checked. So d square a by dx square. What is the derivative? This is expression there. Okay. That is d by dx of, I have to take, this is the first derivative expression. I can simplify this one as a 4x when I take this outside. And what is the 2r square minus x square divided by 2 into, here also I just simplify by taking x square again outside, it become x, and then it becomes 4r square minus x square, so that x cancels, and this is. So you need to find out the derivative of which expression? 2 into 2r square, that is 4r square minus 2x square divided by root of 4r square minus x square. You have to find out the derivative, and I suggest you not to waste much time for finding the derivative and showing that it is a negative, because we have only one value, and it is better you directly write that derivative at the point is negative, because if more than one value is there means there is a meaning of checking, but it is very important that you should mention by sentence that the second derivative at this point is negative. So let us see what is the so you have to, of course there is nothing wrong if you find out the derivative and write it, but it is advised that wasting the time for writing the derivative and that is not the attention required. So I'll say that it is negative at x is equal to root 2r. So because we want to show that it's a maximum. Of course, you can find out the quotient rule and find out the derivative also. Now you got x is equal to root 2r, and let me see what is the value of y. You have what is the y? Y, that formula was the root of 4r square minus x square was that y. So when you put x is equal to root 2r, you have 4r square minus x square. X square is 2r. So it is 2r square. That is root 2r. So you have x is equal to root 2r and y is also root 2r. It shows that the length and breadth of that rectangles are equal. So when length is equal to breadth, it is a square. So finally, what is we have proved is when the area of this rectangle is inscribed, the rectangle is maximum, surely that rectangle will become a square. That is what we have asked to do, and we have proved it also. So with the help of the maxima and minima condition, derivative conditions, we could do it. So there is a lot of applications of the 10th class result is also available there. And one more question I'll explain. You are given a closed cylinder. Right circular cylinder, we call it as right circular cylinder. You are given the volume of the cylinder. Given volume is equal to 100 cc cubic centimeter. Volume is given. And surface area. Given the volume, surface area is minimum. Then find the dimensions. This is the question. So what is the question? Given a right circular cylinder whose volume is 100 cc and surface area is minimum. If the surface area of this cylinder is minimum, what are the dimensions? So dimensions of the cylinder means that is the base radius, and I take this base radius as x and y. I take it as a variable because it is a varying cylinder. See, if I draw like this, that means base radius is more and height is less. It will be like this. So what are the dimensions of this cylinder whose volume is 100, fixed volume? If the height is less and this breadth is more, it also contains the same quantity, no? So it is a varying cylinder items. That is why I take it is x and y. Normally we take r and h. So here I take it x and y. There is nothing wrong if we take r and h also, but we have normally a concept of that x, y, z are the variable and r, h are constant. To avoid this one, to keep that in mind, I am taking this x, base radius and y. So what is given is volume is given, and when the surface area is minimum, when the surface area of this cylinder is minimum, what are the dimensions? So we know that the volume of a cylinder is pi r square h. So here it is pi x square y. Volume is given as 100. So 100 is equal to pi x square y. Or I can get y is equal to 100 divided by pi x square. So this is which convert one variable in terms of other. It is very important this just or this type of problem. So y is equal to 100 divided by x square. Now what is to be minimized? The surface area of this cylinder is to be minimized. So what is the total surface area of the cylinder? Here x square, here one circle, here one circle. So pi x square plus pi x square. 2 pi x square is the two base circles, and then curved surface area of the cylinder 2 pi rx, 2 pi xy. Okay, so 2 pi x square plus 2 pi xy. I can take 2 pi x as common outside, say x plus y. This is the surface area of this. S is equal to 2 pi x into x plus y. What is y? 100 divided by pi x square. So that the function surface area function is completely now in terms of x. Now we can apply the maximum minimum condition. Let me multiply it. That is 2 pi x square plus 2 pi. When you multiply it is 200. Pi cancels. 1 x cancels. So this is surface area. For maxima, so for minima, the condition is minima. ds by dx should be 0 and d square s by dx square should be greater than 0. For it is because it is a minimum. Now when ds by dx is equal to 0, when I take what is the derivative of this is 4 pi x, then 200 into 1 by x derivative is minus 1 by x square. And then it is equal to 0. What is we getting? So 4 pi x is equal to 200 divided by x square. Cross multiplying 4 pi x cube is equal to 200. And then 4 cancels. You have x cube is equal to 4 cancels. So it is 50 by pi. Or x is equal to 50 by pi raised to 1 by 3. This is the value of x. Again, we got this value of x by taking ds by dx is equal to 0. It can be a maxima also. So there you need to check the other portion, that means d square s by dx square. What is the first one? This is the first derivative. 4 pi, then minus 200 into 1 by x square derivative is minus 2 by x cube. So it is 4 pi minus plus 400 divided by x cube. All positive only. When you substitute this value of x there, you will get positive. So directly I say that d square s by dx square at x is equal to 50 by pi raised to 1 by 3 is positive. This value is positive. So when that value is positive, it is a minima. So x is equal to 50 by pi raised to 1 by 3 is minima. So now you got the value of x, and what is y? Y is here. Y is equal to 100 divided by pi x square. That is 100 divided by pi into x. 50 by pi raised to 1 by 3 its square, so 2 by 3. So it is 100 divided by pi. 50 by pi raised to 2 by 3. I multiply by 50 by pi raised to 1 by 3 to the numerator and denominator. It is a rationalizing process. 50 by pi raised to 2 by 3 is the 50 by pi 1 by 3 is multiplied in the numerator and denominator. So what do you get there? That is 100 into 50 by pi raised to 1 by 3 divided by denominator you have pi into 50 by pi raised to 2 by 3 into 50 by pi raised to 1 by 3. 2 by 3 plus 1 by 3 it is 3 by 3. So it gives 50 by pi. This is getting cancels and this is 2. So 2 into 50 by pi raised to 1 by 4. This is the value of pi. So you got x. X is equal to 50 by pi raised to 1 by 3, and y is equal to 2 times it. I can say it is 2 times x. So you got what are the dimensions of this cylinder? X, that is the base radius, is equal to this much and its height is equal to this much. To have the minimum surface area with the given volume of 100. This is a way of finding out it and share this.